Hello and welcome. In this lecture, we are going to start first chapter on physics, that is units and measurement. The key objectives of this chapter is learn the system of units, identify base quantities in different units, change units from one system to another. Now, what is measurement? Science and engineering are based on measurements and comparisons. Therefore, rules are needed on how things are measured and compared. Experiments are needed to establish the units for those measurements and comparisons. Therefore, one purpose of physics is to design and conduct those experiments. Now, there are different physical quantities to be measured, like length, mass, time, force, pressure, temperature, etc. Each physical quantity is measured in its own unit. Now, what is a unit? A unit is a unique name assigned to measures of that quantity. Therefore, unit of length is meter, unit of time is seconds, and unit of force is Newton. It is of paramount importance that scientists and engineers around the world agree to definitions of those units. Once a standard is set, procedures to express the measurement in terms of standards must be worked out. Now, depending on the magnitude of the quantity to be measured, devices needs to be designed for accurate measurement. For example, a ruler may be used to measure length of a book or any similar item, but it cannot be used to measure the size of an atom or distance of a star from the earth. Therefore, different devices are required to measure different length scales. Now, there are many physical quantities to be measured, and most of them are not independent. They can be represented as a result of mathematical operations on other physical quantities. For example, speed can be expressed as a ratio of length and time. These physical quantities which are dependent on other quantities are called derived quantities. All other physical quantities which are independent to any other physical quantities are called base quantities. Base standards must be both accessible and invariable. Accessible means it should be available to all the scientists, and invariable means its value should not change with location. Now there are few systems of units used to express measurements. The internationally accepted system of units is SI units, also called the metric system. In SI units, 7 physical quantities are picked as base quantities by General Conference on Weights and Measures in 1971. These base quantities are length expressed as meter, mass expressed as kilogram, time expressed as seconds, temperature expressed as Kelvin, current expressed as ampere, luminous intensity expressed as candela, and amount of substance expressed as mole. If we want to express very large or very small quantities in terms of base quantities, we can do that as follows. 10 times the base quantities is expressed as deca, 100 times the base quantity is expressed as hecto, 1000 times the base quantity is expressed as kilo, 10 to the power 6 times as mega, 10 to the power 9 times as giga, 10 to the power 12 times as tera, 10 to the power 15 times as peta, 10 to the power 18 times as exa, 10 to the power 21 times as zeta, 10 to the power 24 times as iota. Similarly, 1 by 10th of a base quantity is expressed as deci, 1 by 100th of a base quantity is expressed as centi, 1 by thousandths of a base quantity is expressed as milli. Similarly, 10 to the power minus 6 is expressed as micro, 10 to the power minus 9 as nano, 10 to the power minus 12 as pico, 10 to the power minus 15 as femto, 10 to the power minus 18 as atto, 10 to the power minus 21 as zepto, 10 to the power minus 24 as yocto. Apart from SI system of units, CGS and FPS system of units are also in use. CGS stands for centimeter gram second and FPS stands for foot pound second. So unit of length in SI is meter, in CGS is centimeter, and in FPS is foot. Unit of mass in SI is kilogram, in CGS is gram, and pound in FPS. Unit of time in all the three units is seconds. A measure of a physical quantity can be expressed in different units using conversion. For example, 1 meter is equal to 100 centimeter, which is equal to 3.2808 foot. Similarly, 1 kilogram is equal to 1000 gram, it is equal to 2.2046 pound. So, how can we express one measurement in different units? We can do this by changing units. To change units, we multiply original measurement by a conversion factor. A conversion factor is a ratio of units that is equal to unity. For example, 1 minute is equal to 60 seconds. Therefore, to convert time from seconds to minutes, we multiply it by 1 minute by 60 seconds. And to convert time from minute to seconds, we multiply it by 60 second by 1 minute. This process is called chain link conversion. To summarize today's lecture, today we have learned system of units SI, CGS and FPS. We have learned base quantities in different units. We have learned factors to represent very large and very small quantities. In the next lecture, we will learn about standards of measurements for length, time and mass.